Okay, so we're on our last page of the 15.3 notes. On the first page, we talked about range and interquartile range, us telling how far apart our data is spread. Another thing we can use is standard deviation. And standard deviation is probably the most commonly used, and it is used for the spread of a data set. So it measures deviation from the mean. So it takes each piece of data and looks at how far it is from the mean and then kind of takes an average of all of those. Now, it's actually kind of complicated to do standard deviation, so we're not going to do the calculation. We're just going to talk about it a little bit. So the standard deviation helps measure the degree of consistency. A small standard deviation tells us the data are consistent, meaning they're very close together. A standard deviation of 0 means that all the data values are the same. So if we look down at examples for example 5, if we look at B, notice they're all the same. So that would actually be a standard deviation of 0. If we get a large standard deviation, it tells us that the data are very spread apart. So all we're asked to do on number 5 is determine which of the data sets would have the largest standard deviation. So one thing we can look at is we can kind of see how far the data is spread from each other. So if I look at this first one, you'll notice a pattern. It's just going up by 1 each time. So we would say that that data is not spread particularly far apart. Now we already know B has a standard deviation of 0. Now if we look at these, we've got all of these that are the same, and then we jump by 2, but then all of these are the same. So I'm trying to put in little plus zeros and plus 2s. So those are actually not spread very far apart. But if I look at the last one, there's a plus 4, a plus 3, a plus 2, a plus 2, and a plus 4. So if I compare the 3 data sets, I would say this one, the data is definitely has the most spread to it. So we would say that this one has the largest standard deviation. And like I mentioned before, we're not going to actually calculate it. It's just we want to look at them and see which is the biggest. And then, of course, B would be the smallest because we know that it's 0. All right, one other thing that you may have heard of before is mode. Mode is the number that occurs the most often in a data set. It's used a lot for non-numeric data, like favorite color, favorite type of music, things like that. There can be one mode or there can be no mode. So you get no mode if every value occurs once. Now, if you have values that occur more than once, you pick the one that occurred the most often. If there's a tie, then you can have more than one mode, so that's a possibility. So if we look at number 6, if we're trying to pick the one that happens the most often, it looks like it would be 3. 3 occurs 3 times. 2 and 4 each occur 2 times. So for this data set, the mode or the most frequent would just be 3. All right, so now we're going to take some of our information from the last 2 sections and we're going to put it all together into one example. So if we look at the data set on number 7, I would assume that maybe these are test grades or homework grades, something like that. So we have them ranging all the way from 0 being the lowest score to 91 being the highest. So if we want to go back and fill in some information, we know that our minimum value would be 0 and our maximum value would be 91. Now we could also find the range if we needed to, right? We could do max minus min. But next it asks us for the quartiles. So if I count, there are actually 20 scores here. So if we want to try to get our quartiles, I need to start by finding the middle. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that should be the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's going to be my median or my Q2. Okay, so I have to find that first even though it's not listed first. So I want the value halfway between 71 and 74, meaning I need to find the average, and it comes out to be 72.5. All right, so now I'm going to take the first half of the data. So that's going to be 10 test scores. So I'm going to go up 1, 2, 3, 4, 5. And right here should be Q1, because I've got 5 scores on the left and 5 scores on the right. So that's going to fall halfway between 58 and 64. So I'm going to add those and divide by 2. And that comes out to be 61. All right, then I need Q3, so I want the middle of the top half. 1, 2, 3, 4, 5. That's going to fall between the two 79s. So if I average together 79 and 79, I'm just going to get 79. All right, so now we have interquartile range. Remember, this is Q3 minus Q1. Let me switch back to my other color. So that would be 79 minus 61, which would be 18. Then we're asked to do the lower limit. So the formula for lower limit is Q1 minus 1.5 times the IQR. So Q1 was 61 minus 1.5 times 18, and that comes out to be 34. So that's our lower limit. Our upper limit is Q3 plus 1.5 times the IQR. So Q3 was 79 plus 1.5 times 18, and that comes out 106. So these give us the limits, the lower and upper limits. So anything lower than 34 or higher than 106 would be an outlier. Now our highest score was 91, so we don't have anything higher than 106. But notice we do have a couple of scores that are less than 34. That would be 0 and 11. So we're going to list those as our possible outliers. So now we're going to take all of this information. On your box and whiskers or box plot, depending on what you call it, you put what's called, sometimes called the 5-number summary. And the 5-number summary is your minimum, your Q1, Q2, Q3, and your maximum. All right, so first thing I'm going to do is draw a number line. And I want to get all the scores maybe from 0 to 100. So let's put 0 here. I'm going to try to evenly space these. I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so I'm going to take each of my numbers. My minimum is 0. I'm going to put a little line there. My Q1 is 61, so I'm going to find 60, go just a little bit above it and put a line there. Let's see. Oh, that was supposed to be Q2. I didn't get that on there. So Q2 is 72.5, maybe about right there. 79 is just below the 80. That'll be right there. And then the maximum was 91. It'd be about right here. So what I do with the quartiles is I'm actually going to build my box out of those. So I'm going to take those 3 lines and I'm going to build my box. All right, then the whiskers go from the box to the minimum and the maximum. All right, so that would be my box plot, and that has all of my numbers on it. So what I might want to do next is do a modified box plot. So I'm going to use the number line that I already drew, but what I do for the modified is I take the outliers out. So remember, my outliers are 0 and 11. I still want to mark them, so I'm going to put a little star at 0 and another star at about 11. And then I'm going to find my next smallest value. So if I go back to my test scores, my next smallest value is 56. So I'm going to use that as my new minimum. So 56 would be about right here. And then the rest of my box stays exactly the same. So I'm going to try to keep, maybe I should use my straight line tool. I'm going to try to keep the box exactly the same as the one above it. Okay, so I'm bringing those lines down. And then my max is still 91. Not my straightest lines ever, but that's okay. So the idea behind the modified box plot is, let's just say I'm the teacher and I'm looking at the test scores. If I look at the first one, it's really hard for me to tell how many scores there are between 0 and, what is that, 61? So I can't tell if there's a lot of scores there. What I do know is that half of my scores are in here. All right, so there's half my data. But if I look down at the bottom one, notice I can tell I have something around 0, something a little bigger than 10, but then I can tell that my next biggest score is somewhere around 55, 56. And so I can really see where my test scores fall. Really, they're between 56 and 91. Okay, so a modified box plot gives a little bit more information. So you basically take the outliers out, but you mark them with stars, and then you move to your new minimum, which in this case would be 56. So I'm just going to put a little, I'm going to call this the new minimum. And then over here, I have my outliers.